I'd like to turn things over to one of the presenters we met this morning, Clark Chapman, who's at the Southwest Research Institute in Boulder, Colorado. He's a planetary scientist whose research has ranged around a variety of topics and has worked on science teams for Galileo, Near-Earth Asteroid Rendezvous mission, and Messenger. Today, he'll be kicking off our series of presentations for the afternoon. So please welcome Clark Chapman.
Okay, thank you, Ryan. I'm going to talk about how this impact hazard sort of compares with other natural disasters, and also how did this topic even come about? What's the history of thinking about asteroids striking the Earth? But I'm going to first sort of, okay, not clicking. Okay. I want to spend a little time on this diagram. It'll be a recapitulation of some things that were said this morning, but we've got new people joining us. Sort of go clockwise from the upper left to the lower right, and you'll go from things that are very small that strike the Earth, and they strike the Earth very frequently, to things down here in the lower left that are very rare and very big and very dangerous, and everything in between. What's shown here in blue is kind of the time scale in which things like this hit the Earth, and what's shown in green is sort of a typical size of these kinds of things. And so let's start off with, if you go out in the dark sky, kind of away from the city and away from the full moon at night, you can see meteors every once in a while. They hit the Earth, many hit the Earth per second. But these are harmless little flashes of light in the sky. Then, much more rare, things that hit, I don't know, every week or so hit the Earth, are things that actually land on the ground as meteorites. There was a talk this morning about picking up meteorites. In the early 60s, there was on a Friday evening an event in the sky over the eastern United States.
I believe that's correct.
And a rock came down from the heavens and damaged this automobile in Peekskill, New York. Those kind of things are made by boulders about yay big, and as I say, about every week or so. Now, every few decades, something like Chelyabinsk happens. That's this thing that happened 2 years ago, a giant explosion, half a megaton over a city with a population of 1 million in Siberia. That's when a house-sized thing hits. This is the hole it made in the ice-covered lake at the time. Then every few centuries, there's something the size of a building, you know, kind of bigger than what we're sitting in. It's what made this Tunguska disaster in an unpopulated part of Siberia a century ago. Now, every once in a while, something the size of a mountain strikes the Earth. Now, Jupiter's a much bigger target, so actually back in 1994, comet Shoemaker-Levy 9 struck the planet Jupiter and made brilliant flashes and left dark clouds the size of the Earth in the atmosphere of Jupiter. But these kinds of things happen on the Earth only maybe every 500,000 years or so. And then, of course, there's things like what happened 66 million years ago when something like 8 miles across struck the Earth and wiped out a whole lot of species of life and so on. So that's very frequent, very small, very big, very rare.
Oh, no worries.
Okay, so the very big things, this is just the KT boundary event that wiped out the dinosaurs. It really wrecked the ecosphere of the Earth at the time. But here's a ruler here, and an inch is about yay big, and this is the boundary layer in the geological record. So what can really damage the ecosphere isn't so important for damaging the Earth as a planet. But it's the greatest destruction energy per unit time that can happen. It happens, you know, in hours to years is the destruction of the ecosphere, which is unlike any other natural disaster. Now, much smaller, but still very dangerous, are things that could threaten civilization, things a mile or two across. And here's the kind of things that can happen: tsunami, dust obscuring the sunlight worldwide, wildfires, poisoning of the biosphere, and so on. And then we can have still more frequent, more often, smaller things. Oop, went past one here. There. The Chelyabinsk event, where this explosion happened in the atmosphere over Chelyabinsk, Russia. This was something only 20 meters across, which I guess is sort of the size of this room we're in. Maybe a little small, I don't know, something that size is what exploded and did this event over this city. And that's kind of the thing that we're worried about happening, something like this or bigger that could destroy things by asteroids not yet discovered. Oop. Okay, the history of the impact hazard. You know, a couple hundred years ago, we knew nothing about what comets or asteroids. We hadn't found any asteroids except Ceres and Vesta, but comets were unknown things in the sky, frightening. People thought they might be dangerous, but we had no idea. Now I'm going to give you a bit of the history from the perspective of the news media. Here's an article that appeared in a London newspaper in 1931 about an impact in Brazil. Now we don't know for sure that this thing happened. It's plausible it did, but right from the beginning of treatment in the newspapers was quite sensational, you know, menacing and huge bombs and hurricane of flame and so on. Now, it wasn't really until the 1980s when we really began to understand there was an asteroid hazard. In 1989, a small asteroid, well, could have destroyed civilization maybe if it hit, flew twice as far away as the moon. And this was the first time that a near-Earth asteroid made the front page of the New York Times. And it was called a near miss. It hadn't happened, they said, you know, since 1937 that we saw something come that close. Well, the reason it hadn't happened since 1937 is that we weren't really looking. As was shown in the animation just beforehand, the discovery rate was really way down. We knew very few of these things. These things actually happen very frequently, coming twice as far away as the moon. It's not really a near miss, but near miss day, Google near miss day. That's the first asteroid day. I don't know who celebrates near miss day, but a lot of hits on Google honoring that day in 1989 when there was that first near miss. Okay, here's another thing that happened. In 1998, an asteroid was predicted by the then leader of the Minor Planet Center at Harvard that a 1 to 2 kilometer sized asteroid had a 1 in 1,000 chance of striking the Earth on 26 October 2028. And that could destroy civilization if that calculation had been correct. Unfortunately, despite headlines, now we're in the top half of the front page of the New York Times. And you see what the New York Post said and what Time magazine showed. Fortunately, that calculation was an error. If the calculation had been done correctly at the time, the chances of hitting in 2028 were 10 to the minus 42nd power. In other words, 0.00000000 out 30, 40 times, and then 1. It just wasn't going to happen, but it sure captured a lot of attention. And then, of course, we have these movies that happened in the late 80s. Deep Impact wasn't so bad. It was kind of okay, but most people saw Armageddon. It was actually nominated for 4 Oscars, including Best Visual Effects. The visual effects in Armageddon bear no resemblance to the reality of an actual asteroid or comet. But that sure woke people up to the asteroid hazard. A lot of people know about it, and a lot of people have misapprehensions because of how misleading that whole story with Bruce Willis was. Now, this didn't make the news so much, although I actually heard it in a news broadcast in a rental car at the time, but in 2008, a very important thing happened. A small asteroid, about 3 meters across, about three times as I can stretch my arms, was discovered by this telescope near Tucson, Arizona. And very shortly thereafter, they predicted that 20 hours later, it would strike at a particular minute in particular location in the desert of Sudan, just south of the Egyptian border. And it did. It was the first time we ever discovered an asteroid in the sky, predicted it would hit the Earth, and it hit the Earth. Now, it was a very empty place where it hit. There weren't very many pictures of the thing going through the atmosphere as a big, bright super bolide. But here is a picture of the train, the smoke and stuff left in the stratosphere immediately afterwards. And then Peter Jenniskens from the SETI Institute near here rushed over to the Sudan and got some students from the University of Sudan to go out in the desert and find pieces of this asteroid. And something in the order of 1,000 pieces have been found of this meteorite in that desert. And between the discovery and the impact, all kinds of observatories were able to make measurements of the asteroid so we can compare what we think we have been learning from these remote sensing observations, spectra, and compare with what actually hit in the ground. So the history really is there was no impact hazard before 1981. Then we had the view that the very large ones would destroy civilization, but we had no knowledge of asteroids doing any damage until they actually struck. Then 15 years ago, we decided that we were finding these larger than kilometer-sized asteroids, and they were found not to be a danger during the next century. But Tunguska, we thought, would strike every 4,000 years, and small near-Earth objects smaller than 50 meters weren't dangerous at all. And now we realize small ones are much more dangerous than we thought, and there's many more of them than we thought. We still haven't found very many of them, though. And the death threat has therefore been going down, especially for the big ones that we've been finding. The smaller ones, this is a 100-meter size asteroid, and this is a 1-kilometer size asteroid. The threat's been going down. And so asteroid danger's very small, like this little part of the pie chart compared to war, epidemics, and so on. And the chances of dying from an asteroid, thanks to the Space Guard survey that Dave Morrison and I originally in 1994 estimated to be about the same as dying in an airplane crash, have gone down to where it's like the danger from a fireworks accident. I think I'll pass by this complicated graph. But, as you think about the asteroid disaster, we had a planetary defense conference a few months ago in Italy, and there was a tabletop hypothetical exercise which plotted this path of where an asteroid disaster might happen, just hypothetical. But then 2 weeks later, an actual major earthquake happened in Nepal. And so you have to put the asteroid danger in context. The asteroid danger is serious, like climate change, has different attributes. They're real, they happen on different time scales, and they have different chances of happening. Climate change is happening. Asteroid impact is very unlikely to happen, but it sure could have global effects in a rapid period of time. So, last slide. The hazard is real from asteroids, and it compels us to contemplate the most extreme possible environmental disaster and put the lesser ones in context, and to distinguish between societal threats like terrorism and the regional and global natural catastrophes. Many threats to society and our lives are happening right now today. Asteroids are in our future, most likely as flashes of light in the sky, as places to travel to, as fuel stations for a spacefaring civilization, but in the very unlikely event that one threatens us, it's the one kind of disaster we know how to prevent. Warn people or actually deflect the asteroid so it doesn't happen. Thanks.